Hey everyone, Andrew here. I've been asked before about using Vue with Laravel and Stripe, specifically with the Cashier package, in order to process transactions or fulfill a payment. I've also been asked to show more complete projects that use the full front and backend stack from start to finish. So that's what I'll be showing off. I'm going to be creating a very simple e-commerce application that will have a variety of items, let you add them to a cart, display your total in that cart, and take a credit card payment that will be processed through Stripe. All of this will be powered by a Vue Frontend SPA and a Laravel Backend API. Alright, let's get started. What we have here is a blank Laravel 8 application right out of the box. The first thing we'll need to do is create our models and migrations for the data that we'll be saving in the database. Since this is an e-commerce application, we'll need a product model. And passing in the migration flag here, we'll create our migration files using this single artisan command, so we don't have to go back and create those manually. We could use a category for each of the products too. And an order model, which will store and track completed purchases. Let's open up our migrations and start generating the data structure that we want. First, the users table. This one is included by default in new Laravel installations and comes with a basic useful table layout. We're going to modify this slightly, however. Let's take out the email verified attribute. We won't be using that. And instead, let's add in fields for the user's address, city, state, and zip code. Alright, that looks good. Let's move on to the products table and think about what data we'll need for each product. Probably a name and a slug. This way we can reference a URL-friendly name when navigating the site instead of just an ID. A description for the product, and of course, a price. I'm storing this as an integer for two reasons. One, I just like dealing with it better, and two, Stripe takes whole integers as the price when dealing with their charge API, so it'll be easier just to keep it the same here as well. Okay, moving on, categories. This should be much simpler. I think we'll just save a name and a slug. Lastly, the orders table. First, each order is going to belong to a particular user, so let's add in that user_ID column. We'll also want to store the transaction ID from Stripe in case we need to provide the user this for reference. I'll also want to store the entire purchase amount here as an integer. Okay, those are our tables all set up. Well, almost all set up. These are just our model tables, but some of these models have relationships that need intermediary pivot tables. For instance, multiple products will belong to multiple categories, and vice versa. Same with orders and products. We can create these tables with artisan make migration, create order product table, passing in the order_product table attribute. And create category product table, passing in the table name category_product. Let's open these up and add in the data for them. It looks like I've made a small mistake in the command line earlier. I should have passed in create instead of table. Oh well, we can just swap out this schema table call for a schema create and move on. So for this order_product table, we'll need an order ID, a product ID, and also a quantity. We'll need to know how many of a product someone purchased, not just what product they purchased. We'll also have to modify the down method to use schema dropIfExists. Okay, on to category product. For this table, we just need a category ID and a product ID. Okay, our migrations are all set. Let's open up our models and make some changes. Starting from the top, our model needs to have a protected guarded attribute set to an empty array. I'm going to do this on all of the models. All of them can have each field mass filled in. As for the relationships, each category is going to have multiple products attached to it. And we can specify that with the belongs to many method, passing in the product model class. Next up, order. Again, the guarded attribute set to an empty array. Each order belongs to a user. And each order also belongs to many products. We can attach the withPivot method to this return here and specify the quantity column. This means that when the products relationship is called from an order model, that extra column that we added in the order_product pivot table will be attached and included in the return. On to the product model. Guarded attribute set as an empty array. And each product belongs to many categories. It also belongs to many orders as well. For the user model, let's get rid of this fillable boilerplate and add in our guarded attribute with the empty array. We can also get rid of this CAS attribute since we're not using email verification. Instead, we can add in our orders relationship, a user has many orders. Alright, models done. Next, I'd like to talk about what it takes to pre-populate our application's database with some test models. I could just use a MySQL GUI program to go in and manually create some test orders or products, but I'm instead going to use Laravel's built-in factories and seeders to make creating test data super easy. If we head to the database factories directory in our app, we can see that Laravel already has a user factory ready to go. Factory classes are super simple. They have a model class attribute and a public definition method. That returns an array of key value pairs corresponding to the columns in the database. The data for those columns can either be hard-coded in or generated with something like this included Faker library. For the user model, we can see that Faker is generating a name and a unique email address. Let's get rid of the email verified at column since we're not using that, and instead add in the additional columns that we added to our migration. We can use the Faker library to generate test values for each of them too. There's address, city, state, and zip code. Now, if we use Artisan Tinker to get a shell into our Laravel app, we can try out our factory and see what a test model looks like. All we have to do is call our user model class's factory method and then chain on make. This will return back a user model object with the generated attributes that we specified in the definition method of our factory. Using the make method doesn't actually save it in the database either. In order to do that, we'd have to use the create method instead. Alright, so now that we know how factories work, let's create some for the rest of our application. PHP artisan make factory, product factory, and then we can autofill in the model class by using the model option, product. Let's create one for our category model as well. And open up our new factory to start scaffolding out the generated data. We only need two attributes for categories, name and slug. The slug is actually going to be a modified version of the name string, so we should generate that value separate from the return. I think for the name, I'm going to use Faker's job title attribute. And since that could consist of multiple words together, and I really only want one word for a category, I'm going to create an array out of potential phrases and just store the first word available. Alright, testing that out. And we have our category factory working as expected. On to the product factory. Again, we'll need a name and a slug. As well as a description which we'll use the Faker real text method for, setting it to a max length of 320 characters. Uh-oh, I just realized I specified the wrong model for this. It should be product, not factory. Okay, moving on, the last column we need to generate data for is the price. In that case, let's use Faker's number between method and have the min be 10,000 and the max 100,000. This will generate a price anywhere between $100 and $1,000. Some pretty expensive stuff in our store. For the name, I think the best option is probably a faked company. We'll use that in combination with a random suffix, like sweater, pants, shirt, etc. And testing that out. Our product factory is working just as expected. So now we have to actually get these faked items into our database, and in order to do that, we can use the database seeder. Open up that class located in the database seeders directory. There's a single function in here, run. Under this is where we'll specify what factories to use to generate our seeded data. We could split this out into separate seeder classes for each individual model, and then just call them all in here, but for simplicity's sake, I'm going to just directly run the factories in this main database seeder. Product class, factory method, and then chain on count, providing how many of the models you'd like to seed. Then the create method finalizes the seed and stores the objects in the database. So we have our fake products and categories created, but we also need to generate relationships between them, or it's not that useful. In order to do this, I'm just going to get all of the categories into an array and run a for each loop on the product models with the each method, passing in that categories array. Since each product has a categories many-to-many relationship, we can use the attach method and pass in an array of IDs to attach specified categories to that product. We'll use the random method on the categories array to pull out just 2 and get their IDs. Okay, this is our setup. Now let's actually get the database structures up and seated. In our terminal, artisan migrate, and then artisan db seed. You'll see that I'm using DCR here instead of PHP, by the way, It's just an alias for Docker Compose run since my local environment uses Docker. Perfect, both went through successfully. We can run tinker, and in the shell get all of the products to see if our seeding went through. And you can see that it definitely did. We have 20 products in our database. Running the same command and attaching the categories relationship to the products, we can see that displaying as expected too. Okay, we have our database structure and data. Now we need an API to access this. Let's open up the routes API file and scaffold something out. First, a products route. This will return a list of all of our products and their categories, compiled through a product controller's index method. We also need a route to post to that will complete a purchase. I'm thinking just /purchase and have that use the user controller's purchase method. Let's go ahead and create those respective controllers with Artisan. And open them up. The user controller's purchase method is going to run when we make a purchase, and for now, let's set it aside. The product controller's index method is going to return back all of the products as JSON. That's accomplished pretty easily, just return product all. Actually, product with categories, so we can display which category a product is attached to on the front end. For something like this, we can also specify which attributes we want to return in that relationship by using a colon and a comma-separated list afterwards. So for this, categories, but only the ID and name attributes of that category object. Let's open up our browser and see if this works. Navigating to /API/products, we get back JSON containing each of our 20 products with the categories they're associated with. And those categories only have the ID and name attributes. We have our super basic API set up. Now it's time to get a front end together for our customers to see. Opening up the routes web file, let's replace the call to the welcome view and return back a view called app instead. This is going to be a Vue SPA, and running in history mode, meaning that it will take control of the history and URL bar fully. In order to make that compliant with a Laravel application, we have to add in an additional route call at the bottom of our routes web file, route any/any, and a closure function returning the same view, app. Then chaining on the where method, where any evaluates as ***. What this acts as is a catch-all. Any route name or combination in the URL bar will return back the app view and will draw the Vue SPA. Alright, let's create that view now. I'm just going to scaffold in a basic template here. Okay, we have our app element, which will eventually be the anchor for our Vue application, a script file, and a style sheet. I want to use Tailwind for this project, so I'm going to set it up now. In our app.css file, we just have to add 3 lines: Tailwind base, Tailwind components, and Tailwind utilities. Next, opening up our webpack.mix.js file, in this empty array, we add a call to require the Tailwind CSS package. This method shown was introduced in Laravel 8. If you're using an earlier version, you may have to get Tailwind installed a different way. All we'll have to do now is actually install Tailwind CSS to our app's dependencies using npm. In our package.json file, let's add a line for Tailwind CSS under dev dependencies. And at the time of this video, using this value is a fix for post-CSS requirement compatibility. Now we just have to run npm install and npm run dev to compile our assets. Refreshing our browser, and we're seeing a blank page, which is expected since we don't have any text or images added into our front end. But if we inspect, we can see our app's template, and we can see that Tailwind is pulling in through the styles inspector. Now that we have our styles added in, let's start working on our script. We're using Vue, and we need a store and router as well. So let's use npm to install Vue, Vuex, and Vue router. Once that's done, let's start scaffolding out our application's main JavaScript file, app.js. Import Vue, import and use Vuex, import and use Vue router, create our router object, history mode as we discussed earlier, and instead of writing out all of the routes in this file, we'll abstract those out into a separate routes.js file. Create our store object with a default state. Products is a blank array. Cart is a blank array. And order is an empty object. We'll also need to add some mutations, or methods that will affect and modify our state attributes. Update products will take an array of products and use them for our state's products array. Add to cart will take a single product object and push it into our cart array. But what if we added the same product twice? We wouldn't want that to be a duplicate entry. Instead, we should update something like a quantity attribute on that product object. First, let's find the index of the product in the cart. If it already exists, let's increment the quantity by 1 and return early. And if it doesn't, let's set that quantity to 1 and push it to our cart array. Okay, removing an item from a cart. That should take an index and splice the cart array, removing just the item at the index. Update order should take an order object and use it in place of the state's order. And finally, update cart should take a whole cart array and replace the state's cart with that. It'll be used whenever a purchase is complete to clear out the cart. Next, we have our store's actions. These are methods that perform a task and then make commits to the mutations that we created above. For instance, get products. This should fetch our products from the API that we made earlier and add them to the state. Axios get /API/products, and then with the response, commit update products, and pass through the whole response data object. If an error crops up, let's just alert it directly to the user. This is a test app after all. We could also use a method called clearCart, which will just commit an empty array to the update cart mutation. Okay, our store is looking good. Let's finalize this script by initializing our Vue app. Pass through our router, store, the app element, and using the created lifecycle event, run the getProducts action. It's a promise, so we'll make sure to handle that accordingly. Oh, we're forgetting our routes file that we specified earlier. Let's get that set up. Module exports an array of route objects. For our first one, it's the landing page, so just a slash for the path, and we'll name it products index. The component will reside at routes, products, index.vue. Next, an individual product at /product/slug, which will use the products slug attribute to fill in that space after /product. It'll be called products show and use the routes products show.vue component. We'll need a checkout route as well, called order checkout. Following the same convention, using the routes order checkout.vue component. And finally, a summary. Name order summary, and using the routes order summary.vue component. Let's go ahead and create these components now. And scaffold out a super basic Vue template in each of them. Something I forgot to mention, the method that I'm using to import these route components lazy loads them and code splits them into multiple smaller JavaScript files. It helps to cut down on large initial downloads when your app boots up, and can make user interaction happen faster for users with slower internet speeds. Let's add in some test text to our landing routes template. Also, add in the router view element under our app's mount element. Compile our assets and refresh our browser. Perfect! We can see our test text here at our landing route. Okay, now it's time to get some actual markup and products on our site. I'm going to scaffold out a basic layout with Tailwind to use as our products index view. Let's use a computed products method that will return the current array of products in our Vuex state. And if there's no products yet, we'll be displaying a loading notice. Using v-else, we'll actually display our products. For product in products, using the ID as the key attribute, we'll have this link out to the individual product page using router link, and the name of our route as the to attribute. This params object takes a list of attributes corresponding to fillable areas in our route definition. In this case, just slug, and it'll be filled in with the product slug. Let's display the categories, and the name of the products, as well as the price. Well, we can't just dump the price in here, we are storing it as an integer. Instead, we'll create a method called formatCurrency, passing in that product's price, and create that method definition below. We'll take the price and divide it by 100 to get our decimal value, returning it as a currency string using the JavaScript method toLocaleString. It'll be in USD currency, but there are a variety of values that you can choose from. Okay, recompiling our assets and refreshing our browser window. We can see our loading element displaying as expected, and our products are showing up. Perfect. The price is displaying how we want it to, and clicking on a product's image takes us to that page. Although it's currently blank because we don't have anything built for it. Let's change that. Opening up our product show.view component, I'm going to scaffold out a basic Tailwind template for this view. Just like our index view, we have a computed products method returning the current products array in the state. But we'll also return back the product of the page that we're currently on. To do that, we just need a single line, return this products find, where the product slug matches the current route's slug parameter. Since we are displaying a price, let's also add in that same formatCurrency method from earlier too. We are displaying the categories, name, and price, but also the description this time. And we'll need a button to add this product to our cart. The click action for this should just be commit add to cart, passing in the whole product object. Alright, let's see how this looks. Clicking on a product and we are brought to a product page. We can see the title, description, and our add to cart button. Clicking it doesn't look like it does anything, but if we open up our dev console and go to the View tab, we can see the current state and that our cart has this product in it, with a quantity of 3, since that's how many times I click the button. We should have somewhere on this app to show how many items are in your cart. Let's head to our app.blade file and add in a header block above our router view element. I just pasted this prepared block in here, but essentially what we have is a header element with a logo, a link to our main products page, and a button that shows how many items are currently in our cart using the length of the cart array in the Vuex state. It also links to the checkout route that we specified earlier. Refreshing, and that looks perfect. It's staying on every view since it's outside of the router view element, and as we click on a product's add to cart button, the number updates accordingly to the variety of products that we have in the cart. Let's get that checkout section working now. Opening up the component, I'm going to scaffold out a basic checkout view. We'll need to store some form data, so let's create a data object for this component. A customer object will contain the customer's first name, last name, email, and address info. We'll also need access to the Vuex state cart array, so a computed property returning that will be helpful. Additionally, the total quantity of cart items, and the total price of all of the items in the cart. Those will both be displayed on the page, so a computed property for each generated with the reduce method will come in handy. For our carts table, let's show the name, quantity, and price of each product that the customer wants. And a button in case the user wants to remove a particular product from their cart. We can just call a commit to the remove from cart mutation that we created in the state earlier, passing in the index of that item to splice it from the cart array. I also referenced this cart line total method earlier. Let's actually add that into our component. It'll just return a price that's calculated based on the product's price times the quantity selected. Okay, time to see this in action. Let's add a few items to our cart, and then click Checkout. Perfect! We are seeing two separate products here, with different quantities and prices that reflect that. Clicking Remove on one of them removes it from the cart, and updates our total just as expected. Now we need to get the customer's information so we can handle the actual purchase. Let's start by adding in the form fields attached to the attributes of the customer object in our component's data. And we'll also add this payment processing Boolean data point. That way, as the transaction is going through, we can disable all of the form fields on the page to prevent anything being changed or double-clicked during it. Alright, all that's missing is a credit card field. Now I think it's time we talk about Stripe. If you happen to be unfamiliar with it, Stripe is a payment gateway that lets you accept credit cards, debit cards, or other forms of payment on your website. A lot of developers tend to migrate toward this platform because of its robust documentation and ease of integration with a variety of different frameworks and backend languages. Laravel itself has a package called Cashier, which as it states provides an expressive, fluent interface to Stripe's subscription billing services. However, we're going to be using it for one-off purchases instead of subscription charges, but I still prefer using this package over Stripe's provided PHP library. So first things first, we'll need to actually install the package into our Laravel app using Composer. In the terminal from our project root, run composer require Laravel Cashier. Once that's done, we'll need to run artisan migrate to pull in the tables and columns for the Cashier package. Then we just need to add this billable trait to our user model. And finally, update our .env file with some keys from Stripe. Let's head over to Stripe so we can get those values. After signing into my account, I'm going to create or navigate to the account that I'll be using for this app. Then I'll navigate to the developer section on the left sidebar and click API keys. That will bring me to a page where I can see the public publishable key and the secret key. Let's copy over both of these to their respective places in our Laravel apps.env file. Okay, now that we have our prerequisites all installed and set up, we can start actually implementing Stripe. For this, we need two separate parts that work together. We need the front-end JavaScript portion that generates and validates a credit card, and the back-end PHP code that will actually charge the card with the generated token that Stripe provides. Let's get the front-end portion added in first. In our terminal at the project root, we'll use npm to install the Stripe.js library. And once that's done, let's add in an element to our checkout view that will hold our card input. It will have the ID card element. We also have our button with a view action of process payment. Let's go ahead and create that method now. This is what is actually going to send the payment information to Laravel and Stripe through our application's backend. Before we can actually see our credit card form appear, we need to initialize the Stripe library and tell it where to build that form. At the top of our component's data object, we're going to add a couple of new attributes, a Stripe object and a card element object. And then using the async version of the mounted lifecycle event, we're going to wait for the Stripe library to load in and attach it to that Stripe data object. Almost forgot, we'll have to actually import the loadStripe method from the Stripe JavaScript library. Alright, once that's available, we'll generate our card element using elements.create, a type of card, and passing through an options object that will allow us to style the credit card form just like our other inputs. After that element is ready, we can mount it using this card element mount and pass through our card element ID for the div that we created earlier. For our base CSS classes, I'm just copy-pasting in the classes that are also on our other form inputs. The last piece we need for this is our public Stripe key passed into the loadStripe method here. Now we could just copy and paste this value from our .env file, but what if we need to update that in the future? Because we're using Laravel Mix to compile these assets, we can actually use the .env values directly in our Vue components with the process.env object. However, there's a caveat. They have to be prefixed with mix underscore. So mix Stripe key. In our .env file, we could just create that mix Stripe key attribute and copy in our public key. But again, I'm not a huge fan of multiple lines that need to be updated for single things like keys or secrets. Instead, we can actually reference the above Stripe key attribute in our mix Stripe key attribute by using quotes and then wrapping the value in a $sign and brackets. When referenced, the mix Stripe key value will be the same as the Stripe key value above it. Okay, let's compile our assets and see if everything is working as expected. Let's add a few items to our cart, head to the checkout, and perfect! Our credit card form is appearing, asking for a card number, expiration, and CVC. There's currently no functionality behind it though, so let's head back into our checkout view component and work on the process payment method. First, let's set the payment processing data attribute to true, so that all of our form fields and buttons are disabled. Then, we're going to call the createPayment method function on our Stripe object, which will validate the card information from Stripe and return to us either a payment method object or an error. Because we are awaiting an async method, we'll have to update our method with async as well. Inside the createPayment method, it's expecting a card argument, the element that the card information is stored in, which we use the data attribute for, and an object containing additional information, like billing details. We'll add in the name, email, and address, which is an object containing line 1, or the street address, city, state, and postal code, or zip code. Okay, after we get back a return, let's determine if an error is present. If so, let's stop the payment processing and just alert that error out back to our customer. However, if there's no error, the payment method is valid and we can continue with the charge. Let's set some additional attributes on our customer object. Payment_method_ID will be the payment method object's ID. Amount is the total full integer price of everything in the customer's cart, calculated by using reduce on the cart array. And we'll also pass in the whole cart array by converting the data attribute to JSON. Alright, after that, let's use Axios to create a post request to our API purchase endpoint that we created, and we're just going to use our whole customer data object to pass through everything to our backend. Whenever a response comes back, let's update the payment processing attribute to false so that our form fields aren't disabled anymore. And commit an update order to the Vuex store, passing through our response data object. Finally, dispatch a clear cart to remove everything that the customer had in their cart, and navigate them to the order summary view. If there's an error caught, we're simply going to turn off the payment processing flag and alert the error out to our customer. Alright, our front-end checkout looks done. Now we just have to work on our back-end API purchase endpoint. Let's open up our user controller file where we added this purchase method in earlier and get to work. We are going to be creating this purchase with the help of the Cashier package, and in order to do that, we'll need to generate a user first. Using the first or create method, we can first pass in an array of values that will be used to determine if a user exists or not in our application. In this case, I'm just using the email address of our customer. And for the second argument, another array of values that will be used to create the user if one doesn't exist for the email pass-through. Let's auto-generate a password for our example app with strrandom and #make. Pass in the name, address, city, state, and zip code, all using attributes from our original customer object generated in the front end. Also, in a production application, we should be validating these inputs both in the front-end side and in the back end. But this is an example application, so let's just blindly trust anything coming through. Now that we have our user object, let's wrap the next part in a try block. Payment equals user charge, and that expects two arguments, a whole number amount and a payment method ID from Stripe, which we stored as payment_method_ID. I'll also need some attributes back from Stripe for our order, so I'm going to get that by attaching this as Stripe payment intent method to our payment object returned. Now, let's create our order. We can use the relationship orders on our user model and create, passing in an array of values that our model expects. Transaction ID is available through our payment object, charges, data's first child, and ID. For the total, payment charges, data's first child, and amount. Our order is created, but we need to attach what products we purchased, and in what quantities, to it. We pass in the full cart array, and we can loop over that by running JSON decode on the input cart item as item. For each of the cart items, we're going to attach the product's relationship to our user and run attach. This expects either IDs as an array, or we can pass through a single ID with the item's ID attribute. For the second argument, we can fill in any additional columns that are in the pivot table. Our pivot table contains a quantity integer, so let's update that with the amount purchased under the item's quantity attribute. And finally, we're going to return the whole order object along with the products lazy loaded into it via the load method. Finishing up our try block, we'll catch any exceptions and just return them as a JSON response. The message from the exception, and a 500 code, which will cause the Axios call to throw an error instead of proceeding as intended. Let's head back to our browser and test out everything that we just added. Put a few items in our cart, fill out our name and address, put in card information courtesy of Stripe's test card number, and hit Pay Now. Our payment button and form fields are disabled, and the payment is processing. And we're at a blank screen, which is good. If we look at the URL, we've passed through to the summary screen. Let's take a look at our Stripe dashboard and see if our payment got processed successfully. And it looks like it did. We have a brand new payment of just over $2,000 for our items that our customer purchased. One thing that I forgot to add in our try catch block, however, was to generate a Stripe customer for our user. Using this create or get Stripe customer method, it will either return back or create and return a Stripe customer, meaning that our user's information will also be added into the Stripe dashboard as well as our actual applications database. Alright, let's move on to our last view, the summary component. I'm going to copy and paste a lot of this from the order page, since my goal here is just to display a table of the products, quantities, and prices that were purchased. I'm just replacing the cart data attribute with an order object. Using a computed property to return this object from the Vuex state that was originally committed after the checkout return sent back from our Laravel API. One thing to keep in mind is that the quantity for our products isn't kept in the actual product object, but is instead stored and referenced in the pivot object attached to it, since it resides in the pivot table between products and orders. Okay, let's test out our application from start to finish one last time, adding in some items to our cart, going to the checkout page, adding in our customer's details and credit card information. Let's pay now. And perfect! We are on our summary page, displaying the total list of items that we purchased, their quantities and prices, as well as the returned Stripe transaction ID in case our customer needs to reference the actual purchase. In Stripe, we can see the actual purchase that took place and the customer's details that are associated with the purchase. Our order has been successfully submitted to Stripe and saved in our database attached to a particular user either found or created. Products for that order have been attached as relationships inside of a pivot table, along with their quantities purchased. Well, that's about it for this video. You've learned how to create a basic API with Laravel and seed a database with generated products and categories. We've created a basic e-commerce frontend using Vue SPA architecture and allowed a customer to progress through multiple screens, selecting products, purchasing them, and viewing their final order. And finally, we've been able to process credit card payments for orders with a Stripe API, courtesy of the Cashier package that we installed and configured in our Laravel application. Thank you so much to my GitHub sponsors and everybody else who continues to support these videos. As always, If you have any questions about the topics in this video, or web development in general, please feel free to reach out to me in the comments or on my Twitter linked below. Thanks for watching.